Okay, so good morning, guys. Once again, yours truly, your OLC of Calculus-Based Physics 1, Miss Looney. So before we start with, before I start my discussion in week 2 and week 3, let's first have a recap on what we have discussed during our last meeting. So last meeting, we already discussed regarding measurement. We say that meter is the basic unit of length. And metron came from the Greek word, or metron is a Greek word which means to measure. And also, metric system is a decimalized form of measurement. And the two types of the SI units includes the base units and the derived unit. I also emphasize in there that base units have a unique physical quantity. So we also have this international treatise that establish the laws of measurements. This includes the NIST and the NPL. NPL for the National Physics or Physical Laboratory. And NIST is for the National Institute of Standard and Technology. And also for the SI units, which means International System of Units, and the modern revised form of the metric system. So moving on, let's proceed with the discussion of week 3 in your LMS, which comprise pressure. So pressure is the unit force per unit, or the force per unit perpendicular area over which the force is applied. In equation form, pressure is defined as P is equal to the force over the area. So F there is the force per unit perpendicular to the force applied, which is the capital letter A. So therefore, in equation form, our formula for pressure is P is equal to F over A. So the SI unit of pressure is Pascal. And 1 Pascal is equal to 1 Newton per meter squared. So you have no doubt hearing the word pressure being used in relation to fluids like the blood pressure and the weather pressure. So in blood pressure, we have this high or low blood pressure. And in relation to the weather, we have this high and low pressure. So these are the only two of many examples of pressure or pressures in fluids. So as defined again, P is equal to the unit force over the applied force, where F is a force applied to an area that is perpendicular to the force. This is the formula of pressure. In addition to the Pascal, so there are many other units for pressure that are in common use. So we have this atmospheric pressure in meteorology, which is described in unit of millibar, wherein 100 millibar is equal to 1 times 10 raised to the 5th Pascal. We also have this PSI, or the pounds per square inch, which is LB over the inches squared, or pounds per square inch, or PSI. This is used as a measure of tire pressure. And we also have this mmHg, or the millimeters of mercury. This is still often used as measurement of blood pressure. So pressure is defined for all states of matter, but is particularly important when discussing fluids. So pressure is particularly important with regard to fluids. Okay, so next, the pressure conversion. The metric units or the metric pressure units includes the following. Again, the bar as the basic unit of pressure in metric system. So under the bar, we have this corresponding millibar, which is equal to 0.001 bars. And the pascals, which is equal to 0.0001 bars. So again, from millibars to bars, you have to consider the prefix milli, which means 1 times 10 raised to the negative 3. And the pascals, which means 1 times 10 raised to the 5th power. So therefore, in millibar, you have to move again 3 decimal places from this from the decimal place right after 1, we have to move 1, 2, 3 decimal place to get the corresponding value of bars in millibar. And also same with pascals to bars. So 1 bar is equivalent to 10,200 kilograms per square meter. And the pressure units commonly used in the USA include also the inch of mercury in the atmosphere, which is equal to 29.92 inches of mercury. So 1 atmosphere is equivalent to 14.7 pounds per square inch. 1 bar is equivalent to 10,200 kilogram per square meter. And 1 atmosphere of mercury is equivalent to 29.92 inches. And 1 atmosphere is equivalent to 14.7 pounds per square inch. Okay, so given also the pressure conversion table in their metric units and the English units. So under metric units, we have bars, millibars, and pascals. The corresponding values in bars, in millibars, and in pascals. And also in English units, we have the inches of mercury and the atmosphere. So 1 bar is equivalent to 1,000 millibars and 100,000 pascal. So 1 millibar is equivalent to 0.001 bars. And 100 pascals or 1 millibars is equivalent to 100 pascals and 0.001 bars. So inches of mercury also is, or we have 29.53 inches of mercury is equivalent to 0.9869 atmosphere, and then so on. So use this pressure conversion table as your reference in converting metric units to English units, or converting metric units from bars to millibars to pascals, and the English units from inches of mercury to atmosphere. Okay, so metric energy units include the following, or the basic metric energy unit is the joule. So under joule, we also have this kilojoule and the megajoule. For kilojoule, it is equal to 1,000 joules. Always remember that kilo is 1,000. Mega is 1 million. So in kilojoule, we have the exponential form 1 times 10 raised to the third power. And in megajoule, 1 times 10 raised to the sixth power. So that's why megajoule is equivalent to 1 million joules and kilojoules is equivalent to 1,000 joules. The energy units commonly used in the USA also includes the following. We have the calorie and the BTU or the British thermal unit. A calorie is commonly defined as the amount of heat energy required to raise the temperature of 1 gram of water by 1 degrees Celsius. But that is dependent on the needed or the energy needed for this task depends on the water's starting temperature. So moving on to this thermochemical calorie, it is defined as exactly 4.184 joules, but in several others, we have different definitions that exist as well. Aside from the thermochemical calorie, which is defined as 4.184 joules, we also have 1 calorie is equivalent to 3.088 foot-pounds. And 1 BTU or the British thermal unit is equivalent to 252 calories. And using this latter definition, 1 calorie is equal to 4.187 joules. So for the energy conversion table, in metric units and in English units, we have the joules for the metric units, and English units, we have the calories and the BTUs. So 1 joule is equivalent to 0.2388 calories and 0.0009478 BTUs. For 1 calorie, it is also equal to 4.187 joules and 0.03968. For 252 calories, it is equivalent to 1,055 joules and then 1 BTU. Again, this conversion table will be your reference as well. So moving on to week 4 in your LMS that comprise temperature. So temperature is a measure of hotness or coldness expressed in terms of any of several arbitrary scales and indicating the direction in which heat energy will spontaneously flow. So example is the direction of a hotter body, one at a higher temperature, to a colder body, one at a lower temperature. So to measure the direction of a hotter body to a colder body, temperature is used. Okay, so we also have the 3 temperature scales that are in general use today. The Fahrenheit or the degrees F, the Celsius or the degrees C, the Kelvin or the K scale. So for the Fahrenheit temperature scale, this is used in the United States and a few other English-speaking countries. And for the degrees Celsius temperature scale, this is a standard in virtually all countries that have adopted the metric system of measurement. And it is widely used in the sciences today. Also, the Kelvin scale, this is an absolute temperature scale, which is obtained by shifting the Celsius scale by negative 273.15 degrees so that the absolute zero coincides with 0 Kelvin. So this is a recognized, or this is recognized as the international standard for scientific temperature measurement, the Kelvin scale. These are the following temperature formula conversion. So from Fahrenheit to Celsius, we have the given formula. Degrees C is equal to our constant, which is 5/9 times the degrees F minus 32. So this is the standard formula in converting Fahrenheit to Celsius. We also have Celsius to Fahrenheit. Our formula is degrees F is equal to the opposite of this one, 9/5 degrees Celsius plus 32. So again, these are all standard formula of temperature conversion. So Kelvin to Celsius, we have K is equal to degrees C plus 273.15. Celsius to Kelvin, we have degrees C is K minus 273.15. And Fahrenheit to Kelvin is K is degrees F plus 457.87. And Kelvin to Fahrenheit is degrees F is equal to K minus 457.87. Okay, so these metric temperature units include degrees Celsius and degrees Kelvin. So degrees Celsius plus 273.1. At sea level, the freezing temperature of water is 0 degrees Celsius and the boiling point of water is 100 degrees Celsius. So the temperature unit also commonly used in the USA is the Fahrenheit. And the temperature unit used in metric system is the degrees Celsius. So at sea level, the freezing temperature of water is 32 degrees Fahrenheit. And the boiling point of water is 212 degrees Fahrenheit. Unlike the metric temperature units in degrees Celsius, which is 0 as the freezing temperature of water and 100 degrees Celsius as the boiling point of water. Okay, so the temperature conversion table includes this one, the metric units and the English units. So under the metric units, we have the Celsius and the Kelvin as the basic units of temperature in metric units. And in English units, we have this Fahrenheit. So the equivalent value of 0 Kelvin in degrees Celsius is negative 273.1. And in Fahrenheit, we have 459.7 negative. And then so on with the different given here to Kelvin to Celsius. So we notice that as the value of Kelvin increases, degrees Celsius also increases. The corresponding value in degrees Celsius also increases, and the corresponding value in Fahrenheit also increases. So this means that the metric units and the English units are directly proportional when you're going to convert Kelvin to Celsius to Fahrenheit. They have a directly proportional relationships. So next, we also have this formula, Fahrenheit to Celsius, Celsius to Fahrenheit, Kelvin to Celsius, Celsius to Kelvin, Fahrenheit to Kelvin, and Kelvin to Fahrenheit. So this Fahrenheit to Celsius, the standard formula is degrees C is equal to 5/9 times degrees F minus 32. For degrees C to degrees F, we have degrees F is 9/5 degrees C plus 32. For K to C, we have Kelvin is equal to degrees C plus 273.15. Celsius to Kelvin, degrees C is K minus 273.15. And Fahrenheit to Kelvin, we have this K is equal to degrees F plus 457.87. And then Kelvin to Fahrenheit, we have degrees F is K minus 457.87. So these are also the standard formula for temperature conversion. So let's have a sample problem. Convert 100 degrees Celsius in degrees Fahrenheit. So you have to list down the given. The given value in here is the degrees Celsius, which is equal to 100 degrees C. So what is required? The degrees F. Since our required is degrees F, we have to use the formula of degrees F in conversion. So degrees F is equal to the 9/5 times the degrees C plus 32. So ito yung formula natin for the degrees F. By applying our formula in degrees F, we will obtain degrees F is equal to 9/5 degrees C plus 32. So by rearrangement, we have 100 degrees C times 9/5 or 9/5 plus 32. So 100 times 1.8, 9 divided by 5 is 1.8. So 1.8 times 100 is 180 plus 32, we have 212. So therefore, the value of 100 degrees Celsius in degrees Fahrenheit is 212 degrees Fahrenheit. So next, we have to convert 50 degrees F to degrees Celsius. Again, list down your given. The degrees F is 50 degrees. And the required is degrees C. So since our required is degrees C, you have to use the formula degrees C is equal to 5/9 times the given degrees F minus 32. So by groupings, 5/9 minus 32 or 50 degrees minus 32 times 5/9. So you have to subtract 50 from 32. We have 18. So we will obtain 18. 50 minus 32 is 18 times 5/9 is 0.55. So 18 times 0.55, we have 10 degrees Celsius. So 50 degrees Fahrenheit is equal to 10 degrees Celsius. So example number 3, convert Fahrenheit to Kelvin. 100 degrees Fahrenheit to degrees Kelvin. So again, we list down the given 100 degrees Fahrenheit. Required is the Kelvin. So formula of Kelvin is equal to degrees F minus 32 times 5/9 plus 273.15. But before conversion, or before getting the value of degrees F to degrees Kelvin, we have to get first the corresponding degrees Celsius. So by using again our formula, degrees C is equal to 5/9 times 100 degrees F minus 32. So regrouping, you have to subtract 100 minus 32, then multiply it by 5/9. So 100 minus 32 is 68. Times 0.55 will give you 37.78 degrees Celsius. So since we already have the degrees C value, we can now use the degrees K formula, which is degrees C plus 273.15. The degree C here is the computed value, which is equal to 37.78 degrees. All you have to do is to substitute the computed value of degree C from our formula, 37.78 degrees Celsius plus 273.15 degrees Celsius, which is our constant. So therefore, 100 degrees Fahrenheit in Kelvin is equal to 310.93 degrees. Okay, so next example. Convert 100 degrees Kelvin to degrees Fahrenheit. So again, list down our given 100 degrees Kelvin. What is required? We have this degrees Fahrenheit. So for our formula, 100 degrees Kelvin minus 273.15 times 9/5 plus 32. So by regrouping, we have degrees Fahrenheit is equal to 100 minus 273.15. So this will give us 173.15 negative times this 9/5, which is 1.8. So negative 173.15 times 1.8. So the answer will be added to 32. So it will give us negative 279.67 degrees Fahrenheit. So now that is our value of 100 degrees Kelvin in degrees Fahrenheit. So those are our formula of temperature conversion. So if you notice, it is easy to convert different temperature from its different units as long as you have the formula. Okay, so that's all for this morning. The week 1 and the week 2 in your LMS. So again, for your assignment, you have to answer the prelim exam in your LMS, provided that you already paid your due before prelim exam, or provided that your exam code is already 1. So pagka naka 1 na yung exam code nyo, it means prelim exam is open for you to access. Okay, so thank you so much guys for joining me this morning session. So if you have questions, I can be reached again via my email at lmmbangsara@amais.edu.ph.